Hi, welcome to our talk. We're going to be talking about Apache PredictionIO and Einstein. But before we start, a couple things. First of all, I'd like to warn you, or I'd like this to be very interactive, possibly. So if you guys have questions, raise your hand, interrupt us. I think that tends to make better talks and everything else. So please feel free to ask questions along the way. Otherwise, we will have time, hopefully, at the end to answer any other questions you got. Let's introduce ourselves real quick. My name is Sarah. Oh, one other thing, I talk too fast. If I start talking too fast, just tell me slow down, and I'll do my best to do so. So my name is Sarah Asher, and I'm a project manager here, or product manager, excuse me, here on the Einstein platform, and I'm also the product manager for PredictionIO open source community.
Hi, I'm Kenneth. I'm a co-founder of PredictionIO, and I'm a product manager of Einstein platform team.
Sounds good. Okay, forward-looking statements. Just so you know, everything we say, take it with a grain of salt. Okay, so the agenda of the things that we want to talk about today. So the first thing is we want to give you an introduction to PredictionIO and how it works. The second piece is we want to talk about how you can integrate PredictionIO within Salesforce. And then the third piece is sort of a little independent, but we want to talk about lessons learned in production. So both of us have spent a lot of time helping build machine learning applications, and we just want to give some tips and tricks for you to use whatever system you happen to be using behind the scenes. Okay. So one of the questions we get asked a lot is, how does PredictionIO fit into Einstein? And so I just want to quickly explain sort of where it is. So you can see here we got the rainbow of Einstein. And the concept of this is that we want to be able to help you and put intelligence into Salesforce in a bunch of different ways. So first of all, we have a bunch of applications already pre-built that require no code. That's on this corner. And that's things like predictive lead scoring. So you can just go into your system, flick a switch, say, hey, I want predictive lead scoring, and all of a sudden, there'll be scores in your system that will tell you whether a lead is likely to convert to an opportunity or not. That's no code because you don't have to do anything other than flick a switch. In the middle, we've got a bunch of different offerings. One I'll point out is that we've got APIs available to do like image recognition and stuff. That requires a certain amount of technical expertise to use these APIs. On the other end of the spectrum is custom ML solutions. And that's actually where PredictionIO comes into the rainbow. The purpose of PredictionIO within Salesforce is to allow you guys to write your own custom machine learning algorithms and own custom machine learning applications. And so that can use data within Salesforce. It could also use data outside of Salesforce as needed. But it's yours to build as you want, completely custom. It does require, however, code, an ability to be able to write code and have some understanding of machine learning. Make sense? Okay.
So next I'm going to talk about what is PredictionIO. So before that, I just want to give you a brief history of PredictionIO. So we started a company in 2013. At that time, our vision is to make sure we want to help developers to use machine learning. So we asked ourselves these following questions, like why using machine learning is difficult, how to empower developers to make it easier to use machine learning. So we realized that there are like millions of applications in the world. Like how do we enable you guys to make every application smarter? So we decided to open source our technologies to help you guys to use machine learning. So this is a photo taken in the early days back in the Palo Alto office. In 2016, we are bought by Salesforce, and then we are accepted by Apache. And now we are part of the Apache incubator project. So since then, the community has been growing. We have contributors and users around the world, like from Japan, Asia, Europe, and also in the States. So we are one of the top open source Scala projects, as you can see by the GitHub star. So
okay. Next. I get to take over now. So as we said, the purpose of PredictionIO was to help people create machine learning applications. And so that sort of begs the question, which is, why is creating machine learning applications hard? And so that's sort of what we want to talk about for a little bit. But to start with, I want to give just a quick definition of what we mean by machine learning. I'm not sure how familiar you guys are with it, so bear with me for a slide. So basically, machine learning is using the past to predict the future. So an example of that would be, for example, you guys are all in the room. You guys probably all have, assuming you watch TV, have a favorite TV show. right? And so I could collect information about every single one of you, your favorite TV show, but also other information, maybe like how old you are, or where you were born, or whether you have brothers or sisters, and take that information, hand all of that as a package to an algorithm on a computer, and what it does is it sort of takes all your data, plays with it a little bit, and then finds patterns within that data so that it can determine, well, if someone is like this age and is from this state, their favorite show is Game of Thrones, is likely to be that. So that's what's called training a model. At that point, once you have the model, then you can score against the model. And what that means is a new person can come up and be like, hi, I'm 38 years old and I was born in the state of Kentucky. Tell me what you think my favorite television show will be. And then the model goes through and says, well, I've looked at all the patterns. You know, your favorite show is going to be, I don't know what show. I Love Lucy, The Monkees, I don't know, something, whatever it happens to be. And so the thing to realize is it is a guess. I mean, it's not a complete guess. It is an educated guess, right? So it's not always going to give the exact right answer. And that's something to realize when you're doing your machine learning algorithms is that it may not give the exact right answer, but hopefully it will give useful information. Does that make sense? OK. So that is sort of what machine learning is. So machine learning prototyping basically has three main steps. First thing is you need to have data, right? Got to have your data, you got to pull it into your system. Second of all is you need to train your model. And there's some steps in between where you have to like, do things to your data and play with it a little bit. Once you actually have your model, then it's ready to serve, and then you can make predictions against that model, which seems very simple, right? But actually creating a machine learning application has a bunch of other steps that you have to consider. OK, so some of the steps that you have to think about. First of all, is setting up your machine learning stack. So even if you go in your own computer and you manage to create this model, you still need to put it into production. You need to have a system that's going to load in your data, a system that's going to train your models, a system that's going to score your models. You're probably going to have integration, right? Because you have this model, but you want to use it in your own application, right? It isn't its own thing. So you need to deal with those sorts of integrations. And then assuming that, that you like your model, you probably want to create other models. And you may want to reuse some of the code, and you want to be able to maintain it so that if someone changes a little bit of your code, it's not going to destroy your system. So there are all these other things to consider when you're actually trying to do the full machine learning application. So I mentioned the machine learning stack, and I want to sort of describe what the machine learning stack is. So taking a look at this thing up here. So basically, in the middle is your machine learning logic. That's the code that you're writing to play with your data and train the model and whatever else. It's going to be using data from your data storage layer. That might be like HDFS, it might be like a Postgres database, wherever you happen to be storing your data. And then you also have to process your code, and process your code on the data, and that's done in the data processing layer. Once that's done, then you need to be able to integrate up to your end user application. And so basically, I want to show you sort of where PredictionIO fits into the stack. OK, first place it fits into the stack is between the custom logic and your data processing and data storage layers. So the thing with PredictionIO, or when you're writing your machine learning logic, you should not have to care about where your data is stored, and you should not have to care about processing your code. So if you guys are familiar with Spark ML, are you guys familiar with that stack? Some of you are. The way to think of this is your data processing layer is Spark, your data storage layer is maybe HBase. But the idea of PredictionIO is you can just write your code like, hey, this is how I want to train your model, and we'll take care of things like submitting the job. We'll take care of pulling the data up from whatever data source you have. And because this is abstracted out in this layer, it means you can do things like say, well, I started in Postgres, but I really want to switch to HBase. And that's actually, assuming you can transfer the data over, that's just a configuration change. You're not going to have to change any of your code on the top of the stack. Make sense? OK. OK, next layer. So we talked about your own custom machine learning code. And so the thing is, if you've ever seen some data scientists, you end up with these huge scripts with lots and lots of stuff in there, and it makes it sort of very hard to read and understand. One of the things that PredictionIO provides is an infrastructure for where your code is going to go. So there's separate sections for where you prepare your data, where you train your data, where you score your data. So it's a way to keep things more easily maintainable and more able to reuse code in various spots. OK. So once you train your data, which is simple as saying PIO train, we provide an engine server. And so what that is an HTTP server where you can ask prediction, you can do prediction requests. So going back to the example I had before, with this event server, you would basically hit an HTTP server saying, "Hey, I'm this old, and this is where my state is," and it would spit back your favorite TV show. And it's done as just an HTTP layer, which means it is super simple for you to integrate into any system you want to integrate into. Another API that we actually provide is the Event Server API. And so I mentioned we have your data store, which is where all your data is stored, but this is an HTML API layer right on top so that you can actually use that to push data into your data store. And again, you don't need to even think about what your data store is. It's just HTTP access. You can just push new events or new data into your system. Okay, and then finally, you got to have administration, right? This is just a command line tool where you can type things like PIO, PredictionIO train, PIO deploy, PIO score, et cetera, et cetera. That's to manage the entire system. Okay, all of that together is the PredictionIO stack, and that is the PredictionIO application. Are there any questions on that and how the pieces fit together? Yeah, go ahead. Oh, OK. So Einstein Discovery is actually different than this. So this is its own stack, separate. This is an open source project that PredictionIO, that Salesforce supports. And so therefore, this is something that you can take separate and build on your own. And it is used for heavy coding. So you actually can go in and change the algorithms and write your own Spark code or whatever else that you want to do. Einstein Discovery is a tool to create predictions within Salesforce, but it's more. If you think about the rainbow slide at the beginning, it's more in the middle of the rainbow. Yeah, where you don't necessarily have to write your own code. But this one, in a way, is more customizable, so it can be definitely used for your particular use case. But it loses some of the simplicity of using something like Discovery. Any other questions? OK?
OK, great. Thanks. So next, I'm going to walk you through an example how you can use PredictionIO in real life. So I'm sure everyone knows YouTube, you watch video. So this is an example, like when I go to a page, because I have watched a few of Salesforce video, you recommend me how to do introduction to Apex. Because I watched Spark, you also recommend me to watch a Scala tutorial. So I'm going to walk you through how you could do it with PredictionIO. So first, you have the end user application. In this case, it's a YouTube or video applications. So the users will go to the application. They will browse the video. They watch it. Then PredictionIO has the event server that collect all the events from your applications. In this example, you'll be all the user video viewing behavior events, whether the user liked the video or watch it or finish watching the video. Then the next step is you can create an engine. The engine basically read all the data from the event server as a training data, and then you fit it, pre-process it, generate features, and then fit it to the algorithm to train a model. So this model training process can be triggered by a CLI command, PIO train. Then the next step is, once you have the model, you can deploy it as a service. So PredictionIO provides CLI command, PIO deploy. So basically what it does is it could create an engine server. The engine server will take the model, load it in the memory, and then the engine server can respond to the real-time query. So your applications can send a query. Like in this example, basically, you're asking, I want to recommend top 5 videos to this user with ID 1. And then the engine server, based on the model, you take the information, and also based on the past behavior of the user retrieved from the event server, you return the predicted result. In this example, it's a top 5 recommended videos ID. So I want to emphasize that this part is a real time. So your application in real time, you send all the events. You can also, every a new user log into your application, you can request the engine to get the predicted result. And then the back-end part is running in the background. So you can have the model training and the deployment can be in different cadence. So it depends on your use case and business requirement. You may set it, we train a model every month or every week or every day. So before just one use case of how you can use PredictionIO, so I just want to show you an example. Like say you want to do an email spam classification. So this is your application is like an email client. So whenever the user marks an email as a spam, you send all the events to the event server. And then just do the same thing. You can read all the emails data as a training data. You train a model to classify whether the emails are spam or not. And then you can also deploy the engine server. The query basically is, instead of asking recommendation, you are asking whether this email is a spam or not. And then the predicted results is the probability of this email is a spam or not. So as you can see, PredictionIO can support easily. Using the same framework, you can use PredictionIO to support multiple use cases. So that's the idea of the PredictionIO. That's the power. Because you can, using the same framework, same structure, same infrastructure, you can create multiple engines. And this engine can be used for different use cases. Like, for example, let's say you are doing e-commerce applications. You can have one engine doing product recommendation. And then you can have another engine to predict how likely the shopper will abandon their shopping cart.
Okay. Implementing an engine. Okay, whoops, I'll go one step before I get there. I already gave the answer away. But basically, so there's a lot of code to do all this stuff. We talked about all these different layers and all these different servers and everything else. So, and to write your own custom code, it takes a while, right, to write all that kind of stuff. And so one of the things that PredictionIO does is it provides templates. And the templates are sort of already solved machine learning problems, already set up with all the pieces already filled in. And then the concept of it is that you can take one of those, download them, play with it, and then modify it to work for your particular use case. And so here's a list of a bunch of the different types of templates that are available. You've got Universal Recommender, you've got similar products, sentiment analysis. It's not listed here, but there's like a basic classification one. So that's one way to sort of kickstart your machine learning project. Everything's set up, just download it and start playing with it, start modifying it.
Oh. So another thing, the next I want to talk about how you can, let's say you have a Salesforce application, how can you use PredictionIO with your Salesforce application? So the first step is to inject data from the Salesforce. So Salesforce has a public API, you can use Bulk or SOAP. So you can write your connector to call this API to get all the data from the Salesforce, and then you can import to the event server. Alternatively, you can also use Heroku Connect, which synchronizes the data between Salesforce and the Postgres database, and then you can take this data and import to the PredictionIO event server. And how you can push back the predicted results back to the Salesforce. So same thing, you can write your custom logic in your Apex code to call a REST API or engine server to ask for prediction. Or you can also push back the result back to the Heroku Connect, and which will synchronize the data back to the Salesforce. Finally, you can also run the whole prediction on Heroku. So Heroku provides infrastructure as a service, so you don't need to worry about managing the infrastructure. And you can run the whole stack on Heroku easily.
Okay, and so I'm going to give a quick demo of that right now to show how to actually put things onto Heroku. So basically, a bunch of the Heroku guys have started creating templates for Heroku in particular. And so I'm going to show you sort of how easy it is to get something up and running on Heroku. And so let me quickly do that. And the screen still works, right? Okay, there we go. So this is my personal Heroku instance. And so what I want to do is I want to create a Heroku application that will run this. So let me jump over here to just a second. If you take a look at this GitHub, which is PredictionIO engine classification, this has all the information that you need in order to start to have a classification engine running on top of Heroku. And the example that this one is doing in particular, and I'll just go down so you can look at it, is basically predicting your phone plan given how much you use your phone. So if you use a lot of data, a lot of text, a lot of voice, figuring out, depending on how much you use each of your types of minutes, which plan makes the most sense for you. And so, warning, this is all artificial data, but this is just an example set for you guys to use. Okay, and so in order to get this working, it's actually relatively straightforward. So I'm doing command line. So this is just a terminal window. The first thing you're going to need to do in order to run this is download the code, which I'm not going to do right now because you guys don't want to watch me download code. But download the project. That's the first thing. The other thing is you'll need to have a Heroku account, which is sort of hopefully self-evident. It's going to be hard to upload to Heroku if you don't have a Heroku account. The third thing is you're going to need the Heroku command line tools. And that's a package that is super easy to install. Just search for Heroku command line tools, download it, install it, and you're pretty much good to go. Okay, so I've already done all those steps so far, but those are really the only steps that I've done. So the first thing you need to do, outside of the fact I've done this before, is you need to create, I'm going to call this demo. I think that's what we want to create. So you want to create your you want to create your Heroku application. So that's the bucket where you're going to be putting all your code. The next thing you need to do after you've created it, hold on, let me. Oh, actually, I want to create this one. I want to call it this instead. Once you've created it, the next thing you need to do is basically tell us that you want this to be PredictionIO. So they've got a build pack already set up for you. The code is open source. You can see right here, all I'm doing is setting this build pack. If you want to see what it does, you can actually download it and look at it yourself. There's nothing hidden there. But the build pack basically helps set everything up for PredictionIO. OK, so you've got your build pack. The next piece is we talked about your event server, which is a layer on top of our, that lets you access your data, right? But you need to tell us what your underlying data is. So what I'm going to do is set up, where is it? There it is. I'm going to set up a Postgres database. And so it's just one line of code. It's very easy to do. It's just the add-on, add Postgres. This is the hobby dev is basically saying, free database with Heroku. OK, one last step. And that is to set a couple configurations, like what's the name of the application and access key. Once that information is all set up, then what you do, is you just push it to Heroku. And so we talked a little about a bunch of the different steps for using PredictionIO. You need to build your code, and then you need to train your model, and then you need to be able to deploy your server to that so you can get predictions back. Me pushing this stuff up is doing all those things at the same time. So I'm not going to sit here and watch this, though you're welcome to watch it. So let me give you one warning, is that the first time you run this, it will probably fail. You'll probably need to change the memory settings to be slightly higher. Don't worry about that. That's actually, if you go to this GitHub page, it'll tell you that too. But you go back, you change the memory system, and you redeploy, and then you're fine, and then it should just work. OK, so once you've done all that, then effectively, you've actually created a server. You now have trained a model, and you've got a server that you can ping to do queries for. And that's what this is showing you. This is just a quick little web page we made up, so nothing special about it. But you can pass in information like 25, this is my voice usage, my data usage, my text usage, and say, choose my plan. And what that basically does is it does an HTTP call, I think it's a post, to the underlying server. And it says, hey, here's the information. Give me a prediction. The underlying server passes back a prediction, and then you have your prediction. So you can see here it says, you should go for my more data plan. It's the equivalent, if you want to look at the curl statement, of posting to your original, posting to your database, posting to your Heroku application, the information, the voice usage, the data usage, and the text usage. And then what you get back is just the service plan, the number that represents the service plan. And then you have your own application take that information and do whatever you want with it. Say, hey, consider this plan, or whatever else. Does that all make sense? So that is, and once you do this, and you can set this up yourself, this isn't hard to do. Once you have your own version of doing this, then you can start playing through the code and look at all the different pieces, and you'll have your own application. OK. So that was the end of the demo piece. Are there any questions on the demo or how to do this piece? OK, we'll keep going then. I have to remember how to start it. There we go. Pop. Demo. Still me. OK, one last thing. So I just showed you PredictionIO in action. But if you really want to see an industrial version of this, how many of you guys are coming back to Dreamforce? Yay, Dreamforce. OK, when you're at Dreamforce, you know how you download the Dreamforce application? There's going to be something in there which is going to actually recommend sessions for you. So it'll say, oh, thank you for all your information. Hey, have you considered these are the talks that you might be interested in? That actually is secretly being powered by PredictionIO and Heroku. So you'll actually be able to try it out. And hopefully it should work really well. Tell us. OK. So the final section in our remaining 6 minutes is to start talking about some lessons learned. And so we broke this up into sort of different spots. So the first spot is when you're starting to create your machine learning problem, or not problem, you're trying to solve your machine learning problem. Things to think about before you start. OK, So the first one is translate the business problem into machine learning problem. That may be self-evident. Yes, of course you have to actually turn it into code. But there are a bunch of things to consider that don't necessarily come across at the beginning. The business requirements, even if you're trying to choose a particular model, the model that you choose may in theory work perfectly for their use case, but they're going to reject it anyways for various reasons. So for example, if you have a model that takes too long to train, and they want to train on retrain every hour, and your model takes 2 hours to train, your model isn't going to work. So all the effort that you went for creating this perfect machine learning, they're not going to want to use. And so there are a lot of other cases like that where the technology, you have to make sure that the technology supports the model that you want to use. So that's thing number one. But thing number two is, at a previous life, at a previous company, there was a company we worked with that never, ever used any model other than logistic regression. So it didn't matter that using, I'm not sure if you guys are familiar with logistic regression. It's a classification model. It is a good one. It's a good workhorse. A lot of people use random forest. But they actually would never use random forest, even if it was a better model. And the reason being was because their sales guys refused to accept anything other than logistic regression. Because the sales guys wanted to make sure they understood the model. They wanted to look at the expression and say, OK, I understand what's happening at every step. I believe this model. I'm going to use it. And so that actually brings to the third point, which is make sure your model will be used. And part of that is the technology piece of it. But part of it is making sure that after you go through all this effort of creating your model and doing scores, that people are actually going to pay attention to your model and pay attention to your scores. So part of it is what I said with the sales guys, which is saying, yes, I believe that, I trust your model, I'm willing to use it. But then part of it is for the end user to give them enough information, enough context for your prediction that they will believe it. And an example for that is actually, I don't know if any of you have played with predictive lead scoring, which is one of the applications within Einstein. They talk, when we give you a score of whether a lead is likely to convert to an opportunity, we don't just give you a number, we actually give this is the reason why we got this number. We say, oh, it's because, I actually don't know what the reasons are, maybe because you're a VP for this particular type of company and you've emailed us a bunch of times in the past or whatever else. But the point is we give the person looking at the record reasons to believe the model that we've created. Make sense? Okay.
Okay. So next I want to talk, so there's a myth in machine learning. People always think it's because of the algorithms make it so intelligent. Actually it's less, I want to say that it's less about algorithm, because today there are many machine learning libraries in today, like logic regression. Oftentimes you are only using a few basic algorithms, like for classification, you will use logistic regression or random forest. For recommendation, you use collaborative filtering. So there are many existing libraries, but the most important part is about the feature engineering. So that depends on your use cases, your business goal. You need to identify what features to use, which require lots of domain expertise, like understanding of the business. Like say, for example, for video recommendation, you need to think about what signal can tell you more about the users. Like maybe sometimes it may not be just about the user click the video. Actually, you may need to use a signal. The user has to actually finish watching the whole video as an important signal. So, yes.
Cool. OK, validating your model. Is my sound still working? Sounds a little different. OK, so first of all,
I think your mic.
Yeah, did my mic get turned off? Hello? Can you hear me? OK, you can hear me. OK, so first thing is run against a lot of real-world data. So there's a tendency to take maybe a small sample of the data, play with it, and say, I've got my model. Chances are, if you take that and explode it to your entire data set, your model is going to change a lot. So you want to make sure that you actually run it against everything, not just a small subsample. The second thing is do a sanity test. If your model is either too good or too bad, you probably want to look at it. Or even if your model seems exactly where you expect it to be, go take a look at it and make sure it actually makes sense. Look at the features that are being used and how important they are. And so there are a bunch of things that can happen if you don't do that. You may have a perfect model that's I've got 100% accuracy. This is great. Chances are it means that you actually have bleed through with one of your features. For example, you're trying to predict someone's height in feet by using their height in inches. Yeah, you're going to have a perfect model, but it's actually meaningless. So you need to actually go through and make sure that the data science makes sense and validate your data science. But the one thing that's sort of weird about this type of project is it's a data science project, and it's also a software project, which means that all the standard things that you think about for a software project, you also have to consider here, which means you should be thinking about tests. You want functional specs. You want unit tests. You want the unit test to test the validity of your flow, make sure there are no bugs and all that sort of stuff, right? So that when people go back and change your code, your system isn't going to get screwed up, basically. Make sense? OK. We've got 47 seconds. We're going to have to go quick.
Okay, so the last thing is the productionizer model. So just like any software system, you need to monitor your machine learning system. So one thing about machine learning is that in addition to the monitoring the functionality, you also need to monitor the model quality, the model performance. You also need to think about what's your business goal. You need to think about your business performance metrics to make sure the model. Sometimes the model may have a very accurate data science metrics like precision, but it may not help your business. So you need to make sure how you can connect your business metrics to your data science metrics.
Cool. OK. If you're interested in learning more about Einstein, here's some places that you can look. So first of all is that you've got demos in the Einstein Discovery Center. In fact, that same Heroku one that we've done is over there. There are trails. There's also a trail on machine learning. So if you're like, this sounds great, but I have no idea what machine learning is, you can learn a little bit about AI using one of the trails. And that is it. And we are over, so we have to stop. Are there any questions? And we're happy to answer a couple quick questions, and then we can hang around and answer questions privately afterwards as well.